Hello. For today, we are going to have notes on how to solve systems of equations with a different method. And I'm showing the table of contents here just to make sure that everyone's up to date and with me. So we started systems of equations right here. We had some practice that we glued into our notebook, and this was graphing systems of equations, and we were graphing them. Then we learned about substitution, and we took notes on substitution, as well as when you go to solve for substitution, there are some special cases where there are no solutions or infinite solutions and what those look like when you're solving with substitution. And today we're going to look at how to solve systems of equations by elimination, which is another method you can use, and that's the final method. And then we'll kind of put all of them together, either using graphing or substitution or elimination. So this is page 65 in your notes. Let's go ahead and flip to that now and fill those in together. All right. So once you go to page 65 in your notebook, you're going to fill this in. I took a picture of this and did upload it to Google Classroom if you'd like to just print this out and cut out the top part and just fill in the blanks that we have here, and then you can write your own work down here underneath. These are two examples that we're going to have today, and then I'll give you a little bit of practice as well with elimination. Elimination, like I said, is another method to solve for systems of equations. If you prefer substitution, once you've learned this method, you can use substitution. If you prefer elimination, you can use this method instead. So we're going to fill in the blanks now. And these are the steps that you're going to take when solving by elimination. So the first thing you're going to do is to arrange your equations on top of each other, as you can see right here. So they're sitting on top of each other like we would do basic addition and subtraction of single or double digit numbers back in elementary school, and we stack them on top of each other. We want to stack them on top of each other so that like terms are in columns. So in these first two blanks, you're going to put like terms, meaning the x's are on top of the x's, the y's are on top of the y's, the equal signs are on top of the equal signs, and the plain numbers are on top of plain numbers, or just constants. The second step is going to be to multiply one of your rows if you need to. So you'll multiply, if needed, the equation or both equations to make it so that one of the variable's coefficients are opposites. So if you look down here, these are not stacked up properly, so we're going to have to rearrange those. But if we look at these are stacked like terms, right? So the x's are on top of the x's, the y's are on top of the y's, and the numbers are on top of the numbers. But what we need to do is we need to get one of these variables to be exactly the opposite of the other. So if this is 5x, we would need that one to be 5x. Or if this is 3x, we would need this to be 3x. Or it can be a factor of both of them. But we always want to use the smallest one. And so looking right here, 4 and 2, I know that those are 2 is a factor of 4. So I can work in this family here. I can multiply this bottom row by 2, and all of a sudden this will now be 4. So I can get them to be opposites. This is negative 4y, and if I multiply this whole row by 2, this would be positive 4y. So negative 4y and positive 4y would be each other's opposites. It has to be the exact like term, but also an opposite. So if you can multiply one of your rows to get one of those variables up to matching the other one, but with the opposite sign, I'm going to put that in parentheses here. We want the sign to be opposite. The number needs to be the same. Then we're going to do that. So if I didn't want to, again, multiplying this whole row by 2 would be the smallest number. It would be the easiest to get this up to a 4, right? Because I know that 2's and 4's are in the same family here. If I wanted to make these match, I'd have to multiply this whole row by 5 to get that to 15. And this whole row by 3 to get that to 15, because 5 times 3 is 15 and 3 times 5 is 15. But that's a lot more math that I'm having to do to both rows. Now it can work because 3 and 5 are both factors of 15, but I can do this one because it's much smaller and much easier and quicker to get to make one of these 4, right? And so you always want to do the easiest and the smallest. The next step would be to add the equations together, combining like terms and eliminating one of the variables, hence the name elimination. So when you do that, when you get them to be opposite signs but equal numbers, you completely eliminate one of your variables. It's gone. And so now you're just solving for the remaining variable. And so that's what you're going to put for number 4. Solve for remaining variable. At that point, it's just one single missing number. It's like solving for x or solving for y. It's the only letter left. Solve for it. Get it by itself. And then the last step is once you've found the value in step 4 for one variable, plug it back into either the original equation or either one of the original equations to solve for the remaining variable. So again, once you have found that one of the variables in step number 4, plug it back into either of the original equations and solve for the other one that you don't know yet. And so we're going to do 2 examples here together, following our steps. So here's the first one and here's the second one that we're going to do together real quick. So looking at this, if I follow my steps, it says to arrange them on top of each other. Well, they are on top of each other, but it needs to be like terms together in each column. And I have an x and a y here, a y and an x, and a constant and a constant. Right now, they're not matching. So what I need to do is switch those. Again, you can move things around on the same side of the equal sign. That's not canceling or undoing or moving. That's just rearranging on one side of the equal sign. When you move across the equal sign is when you have to do the opposite operation. But right now I'm just rearranging this side. I haven't crossed this little fence here, so I'm good. So my actual equation will be 4x minus 5y equals 35. And my new equation underneath it, when I switch those, 2x will come first, and then the positive 5y, and then the negative 5. And I know this 5y is positive because there's nothing in front of it. And if the leading coefficient is positive, you won't see a symbol. If it's negative, you'll see a negative sign. So since there's no symbol, I know that it's positive. And I know this 2x is positive because in front of it has a plus symbol. And that symbol always goes with the variable or the term right after it. So now that I've rearranged them and they're in columns of like terms, I can start working. So I'm going to combine everything together. 4x and 2x is 6x. Negative 5y, positive 5y cancel. So those are eliminated. Bring down my equal sign, and 35 minus 5 is 30. So this is actually what I'm left with. 6x equals 30. I don't have a y at all. So now I'm just solving for the remaining variable. Again, if we look at our steps, arrange them so like terms are together. We did that. Multiply if we need to so that one of the variables' coefficients are opposite of the other, but we didn't have to do that because negative 5y and positive 5y are already opposites, and they're already the same number. Add the equations. We did that. Eliminating one of the variables. We did that. Solve for the remaining variable. That's what we're about to do. So I'm going to solve for x. I need to get that multiplied by 6 away. So I'm going to divide by 6, leaving x to equal 5. Well, now that I know one variable, the last step is to substitute value found in step 4 for one variable back into either original equation to solve for the other one. So again, it doesn't matter which one you choose. I'll just choose this bottom one because it's smaller numbers. 5, 2, and negative 5 are much smaller numbers than 4, negative 5, and 35. So if I have the choice, I'm just going to choose an easier one. So I'm going to take this number and plug it in place of x in either one of your equations. So now we have 5y plus 2x equals negative 5. So this is this equation, but where the x is, I plugged in 5 because I now know what x is. Those letters are only there because we don't know what they are. But the minute you know what it is, you need to plug it in. So I'm going to multiply 2 times 5, and that gives me 10. Bring everything else down. And now I'm solving for y. I'm solving for the only letter that I have left. I need to get it by itself. So this positive 10 needs to move over to the other side. And then anything that's stuck to the variable, you have to divide it away. And a negative and a positive will always be negative. Remember, in multiplication or division, if the signs don't match, it's bad. And so it's going to be a negative always. And 5 can go into 15 3 times. So the answer is 5 and 3. You can also write it as an ordered pair if you like. The x value is 5, the y value is negative 3, meaning there is one solution to the systems of equation. And you can also get these to where the y is by itself and get it into y equals mx plus b format and graph them and see if they cross. You can solve it by graphing. You could also solve by substitution that we learned last week, where you get everything on one side except for one letter, like y equals everything or x equals everything, and then plug everything that you got for that letter in place of that letter in the other equation, and you could substitute it in. And then this is how we would do elimination. I think elimination is a little bit easier than substitution. It just, in my head, makes more sense to get rid of one of the letters and just solve for a missing variable. We can do that. We've done that before. So let's look at our other example. 5x minus 4y equals negative 48, and 3x plus 2y equals 2. These are already stacked on top of each other, and they're already stacked in like terms. So I'm good to go right there. So I can just actually start right from here. So now that they're stacked, I don't see any that completely cancel each other out. So I'm going to have to multiply one of my rows. So like I was saying earlier, if I want to cancel one of these letters, I'm going to choose these two because I can make 2 equal 4 a lot easier than I can make these equal each other, right? In order to make these equal each other, I'm going to have to multiply both of them. I can make 5 equal 15 and 3 equal 15. That's the first common factor they have. But 2 and 4 are much easier. So if I multiply this entire row by positive 2, this will end up being positive 4, which is the opposite of negative 4. So that'll be pretty easy. So I'm going to bring down my first row because nothing's happening to that. And then let's see what happens when I do multiply 2 times this, 2 times that, and 2 times that. Remember, the entire row, everything has to be doubled so that it stays true. You can't just increase one part and not the rest of them. It'd be like saying, sorry about the light. 2 plus 2 equals 4, and then I want to multiply everything by 2. So then it would be 4 plus 4. Well, that can't still equal 4. I have to also increase the answer by 2 as well to keep everything true. So 2 times 3 is now 6x. 2 times positive 2 is now positive 4. And bring down the y that goes with that. And 2 times 2 is 4. So this equation is the same as that. It's just everything is doubled. You see how everything is twice as big? Still true. It's like an unreduced fraction, right? 8 over 4 is the same thing as 4 over 2, which is the same thing as 2. So you can just double everything. So now let's take a look. We can eliminate right here. Those are completely gone. Negative 4y and positive 4y give me 0. So we completely eliminated one of our variables, and now we can just combine the others. 5 and 6 give me 11, and those are talking about x's, so we got to bring the x down. Bring down the equal sign, and negative 48 plus 4 is actually negative 44. Right? Imagine you're down 48, and then all of a sudden someone gives you $4. Now you're only down $44. You're getting closer to 0. And at this point, we need this x by itself. It's the only letter we have left that we're solving for. 11x equals negative 44. So solve for the missing letter. Get that 11 away from it. When it's stuck side by side, that represents multiplication. So to undo multiplication, we divide. X equals negative 4. Now that we know what x is, we can go back to either one of our original equations. And I'm going to choose the bottom one because, again, it's a smaller, it has smaller numbers in it. So to me, that makes more sense. And I'm going to use the original. No need to look at the times 2. We just did that for this step. Plug it into the original. Remember the original equation? So I'm going to say 3x plus 2y equals 2. And I'm going to plug the negative 4 right there. And this way, all I'm solving for is y. I know what x is. So there's not two missing variables, there's just one. Well, 3 times -4 is -12. Bring everything else down. Move this over here. Again, we're trying to get y by itself. So any plain letters or plain numbers, you want to move those first. 12 and 2 can combine because they're both constants. And then you have something stuck to your letter, so you're going to divide it away. And 14 divided by 2 is 7. So we now know the solution to these two equations. When x is -4, y is 7. They will both cross each other at that point. And that is your solution. So this is how you do elimination. I'm going to put a few problems up for you guys to work on today, and make sure that you get your notes. And if you have questions, let me know.